Hello everyone, today we are going to be going over the domain of a function. This will help us continue our lessons on piecewise functions. Yesterday we started with evaluating piecewise functions. Today we're going to be looking at what their domains are. So what is the domain? The domain is pretty much the collection of all the possible x values that are allowed for a specific function. So again, any x value that is allowed to be substituted into the function. And how do we write that in our notation? So there are three ways to do that. So I'm going to go ahead and write those out. First possible way is just when you have a function cut off on like the left side and it goes on forever to the right side. So this would be written as x greater than, because everything to the right. Sometimes with the equal, sometimes without the equal. So I'm just going to write the greater than sign. And then we have some number here, everything to the right of 5, everything to the right of -3. Another way to write it is if the function is cut off on the right side and it goes forever to the left side. So it's going to the left, so the less than direction. So same idea, we have x less than with or without the equals, and then we have a number. And the third possible way is when it's cut off on both ends, so it starts and it stops. So we have to indicate the starting point and the stopping point. So this time we have the x in the middle, we have the less than symbols with or without the equals, and then we have the left and the right numbers where it starts and where it stops. Remember, the one on the left is always the smaller one, and the one on the right is always a larger one. The one on the left is the one that's on the left side cut off, and then the number on the right is where you cut it off on the right side. So let's go ahead and look at some of these functions, and we're just going to be writing their domains. So which directions does it go and how far? So if we look at this first one, which is our line, notice that the line has arrows on both ends, which means that this function goes on forever. So it will forever go to the right and up, and it will forever go to the left and down, which means this function does not get cut off anywhere. So we would not be using any of these really. The only thing is, since something is going forever, we have to write it somehow. So the way we write it for this special case, the one that goes on forever, meaning it goes to infinity, is we're going to write it using the C way, meaning this way. But instead of writing numbers, we're going to write the infinity symbol. So we're going to say it goes on forever to the left and to the right. So the way we do that, we put from negative infinity, less than x, to positive infinity. So it goes forever in both directions. You can also write the phrase all real numbers if you would prefer. All right, for number 2, let's look at the domain of this parabola. So again, we see that it's got these arrows, which means it goes on forever. So yes, it goes down forever down, but as you zoom out, this parabola gets wider and wider and wider. So it gets wider and wider to the right forever. It gets wider and wider to the left forever. So this one also has the same domain. You can plug in any number for x, and you will always get a number for y for it. So that's what the domain is. What x's can you plug in? Let's look at the next one. So this one's different now, like the line, but in this case, it goes on forever in one direction, but it actually stops in the other direction. So it's got a stopping point. So I have two options on how to write this one. I can write it that it goes right forever, like we see in the way of writing it the A way, or we can also write it the C way. Now, the A way would be the most common one because it's shorter, but you can also write it in the C way. So I'm going to write both ways, but again, it's optional which of the two you want to do. So I'm going to go ahead and say it goes to the right forever. It starts at -3 on the left side, and it goes on forever to the right. So it's everything to the right of -3, so all the numbers bigger than -3. So I'm going to write down that my x values are anything greater than or equal to, this one's got the little equal symbol because it's a closed circle, to the number -3. So it's x is greater than or equal to -3. I'm actually going to write it the other way now, and I'm going to write it underneath. And the other way is to do it with both the left and the right break. So, and in this case, it would require me to use infinity because it goes on forever. So again, option number 2 is to write down x less than, so from -3, and you put that equal sign on it. And on the right side, it goes on to infinity. So this is also a correct way of writing it, but again, the one on top is preferred. Let's go ahead and do this last one. This one's the same idea, looks exactly the same as the one on the left, but instead of being a line, it's a parabola. So it's got a left ending point. So again, it starts at -2, and it goes on forever to the right. So it does not ever end because it's got that arrow, which means it goes on to infinity. So it's everything to the right of -2. So I'll write it both ways again. I'm going to write it the x greater than or equal to -2. So x greater than or equal to 2. In case you can't see it on the screen, I'm going to write it up here again. X greater than or equal to -2. And then the other way where you have the infinity. Notice that the one with the number has the equal on it, but the one with infinity does not. All right, let's go ahead and do a few more. All right, so let's look at our next one. This one gets cut off on both sides, so we will be using the C way of writing it with the both numbers on the left and the right, small on the left, larger one on the right. So we're going to go ahead and write down our x and less than or equal to's because of the closed circles. The one on the left is at -4. The one on the right is at +6. Same thing for the next one. It starts at -5 and it stops at +1. So where x is between less than or equal to -5 to +1. So it's pretty much all the x's in between -5 and +1. It doesn't exist outside of that. Let's look at the next one. Now, this is a piecewise function because there's two pieces to it. So we have two domains, a domain for the line and a domain for the parabola. So let's go ahead and do the line first. The line stops on the right side at -3, and it goes on forever to the left. So this is the B case that we have up at the top. So it's everything to the left of -3. So it's x less than or equal to -3. If you prefer, you can also write this the longer way. You have the option of writing it from -infinity because it goes down forever to the left to -3. Notice that this right here is the same as that, but it just has that extra -infinity part. Let's go on to the next one. For the parabola, this one goes from -1 all the way to infinity, or everything to the right of -1. So it's going to be the A case, so x is greater than or equal to -1. Again, if you want to write it the longer way, you can. So I'm going to write the way you can write this the longer way. So we have it goes on to +infinity, from -1 to +infinity. Again, the number has the equals, the infinity does not. One more time, I'd like to point out that this right here is the same as that. They're just backwards, but it's the exact same thing. All right, let's go ahead and move on to the domain of the three lines. I'm going to go from left to right, 3 pieces on this piecewise function. So first one is everything to the left of -4. So it's everything to the left or less than -4. The one in the middle goes from, looks like 2.5 to 2. So we're going to go from -2.5 to, we're going to go with, that one's at 2. We'll just go with 2 on that one, even though it's slightly to the right. Or we can go 2.5 on both ends. Let's just write it that way. So we're going to go from -2.5 or 2.5 less than or equal to x less than or equal to +2.5.